In this video, we'll show how to set up an integral that finds the force exerted by the liquid on a vertical plate submerged into the given liquid. In our case, we have a circle of diameter 3 filled with gasoline halfway, so the water level is right here. And first thing we do to compute the force is we create the coordinate system, one-dimensional, pointing down, so we get to choose the origin. So let's place the origin at the level of the liquid, so halfway in the tank. So this is the origin, this is going to be the x-axis, and then the boundaries for the liquid are then from 0 to 3/2. And now we're going to pick some arbitrary value of x between 0 and 3/2, and we're going to consider a thin strip of height dx. And to compute the hydrostatic force, we're going first to compute the hydrostatic force exerted on this strip. We're going to call it dF, and that force is equal to the pressure times the area. And pressure is rho g, and the depth here is exactly x, because we chose the origin to be at the surface level. So the pressure is rho gx, and to find the area, we know we're going to be multiplying the width by this height dx. And now we have to focus on finding this width. So it is pretty clear that as x changes, this w also changes, so that's why it's a function of x. Now let's take this problem out of this context and let's solve it geometrically. We have a circle of radius 3/2, and we have this line segment of total length w, so half of it will be half of w. And now we're going to bring this measure from the center of the circle to the w, which is in this coordinate system just x. So the relation between x and w is that x squared plus half of w squared is equal to 3/2 squared, meaning w is equal to 2 times square root of 3/2 squared minus x squared. So this is the w as a function of x that we were looking for. So that's the expression that goes here in the setup of the integral. So what we have here is the force exerted on that one strip. The total force will be the integral from 0 to 3/2, and that ends the question. So the answer to the question is right here. So this is the integral that computes the total force exerted on one end of the tank.